after the Boeing Starliner Calypso limped back to Earth without its crew last September. Many wondered if it was the end of the road for the program. At the time, analysts believed Boeing would fight to keep Starliner alive, viewing it as a potential lifeline amidst struggles in its defense business. But now the situation has drastically changed. Starliner has gone from a beacon of hope to a ticking time bomb. The financial bleeding seems endless, with losses now topping a staggering $2 billion. That's 1/6 of Boeing's total losses in 2024. That problem doesn't just mess with the company. Oh no, it's a full-on ripple effect. SpaceX's Dragon spacecraft, the cosmic Uber rescuing the stranded astronaut, now has to rearrange its schedule. As Boeing sinks deeper into a swamp of scandals, from safety incidents to labor strikes and quality control concerns, does Starliner even stand a chance of flying again? Join us as we dissect the fate of Starliner in today's episode. Anyway, our next goal is 100,000, and we need your support to get there. If you haven't subscribed yet, please do. We appreciate your help. Thank you. We're now in early February, and according to NASA's schedule, next month we will see the much-anticipated return to Earth of NASA astronauts Suni Williams and Butch Wilmore, who flew on the Boeing Starliner last June and have been stuck on the ISS ever since. The Boeing Crew Flight Test launched on June 5, 2024, with NASA astronauts Butch Wilmore and Suni Williams experienced several issues including thruster malfunctions as Starliner approached the International Space Station. Helium leaks also posed ongoing problems throughout the mission. After investigation, NASA determined it too risky to return Wilmore and Williams on Starliner. The Starliner spacecraft returned to Earth without a crew on September 7, 2024, landing at White Sands Space Harbor in New Mexico. The astronauts will return aboard the SpaceX Crew 9 spacecraft as early as March 19th. It's safe to say that spending 286 days in space wasn't exactly on the bingo card for this duo of astronauts, especially since the Boeing Crew Flight Test was supposed to be a quick 8-day trip. Now, instead of a short adventure, they're stuck up there long enough to start feeling a series of inconveniences. Last November, shocking images showing Williams's sunken cheeks popped off online, triggering worries about her health as she remained beyond Earth's atmosphere for several months. Fortunately, her health has now stabilized enough for her to undertake a 5-hour, 26-minute spacewalk in January this year. However, homesickness is always on the minds of these astronauts.
Yeah, eventually we want to go home because we left our families a little while ago.
As a result, those involved in the matter were called out again. SpaceX founder Elon Musk recently took to his social media site, X, to blame the Biden administration for this problem. Terrible that the Biden administration left them there so long. He also said that President Trump wants them saved. The POTUS has asked SpaceX to bring home the 2 astronauts stranded on the space station as soon as possible. We will do so. Terrible that the Biden administration left them there so long. President Donald Trump wrote in a post on his Truth Social platform, "I have just asked Elon Musk and SpaceX to go get the 2 brave astronauts who have been virtually abandoned in space by the Biden administration. They have been waiting for many months on space station. Elon will soon be on his way. Hopefully, all will be safe. Good luck, Elon." Those statements align with NASA's plans before those statements, which called on having Williams and Wilmore return on the Crew 9 Crew Dragon spacecraft currently docked to the station, along with NASA astronaut Nick Hague and Roscosmos Alexander Gorbunov, who arrived at the station on Crew 9 in September. However, it is going to be changed significantly. The original plan is that return to Earth would come in early April after the launch of Crew 10 scheduled for late March, enabling a handover between the crews on the ISS. In December, NASA publicly announced a delay of the Crew 10 launch to no earlier than late March, due to issues with a new Dragon spacecraft, C213, specifically with its batteries. To avoid further delays, SpaceX will use the Crew Dragon Endurance C210, which previously supported the Crew 7 mission, for the Crew 10 launch, now targeted for no earlier than March 12th. This switch aims to bring Crew 9, including Butch Wilmore and Suni Williams, home sooner after an extended 286 days in space. Additionally, people are also wondering how Boeing will be held accountable for the current incident. For over a decade, Boeing's Starliner fiasco has burned multi-billion tax dollars for no return. The spacecraft has so far not yet been certified. Sure, thus, NASA has to rely on a sole contractor, SpaceX, to access the ISS, which goes against NASA's principle of redundancy in spaceflight. However, for some unknown reason, the space agency remains determined not to let the Starliner program die. So, what will they do? Well, they intend to throw more good resources to salvage it via two options. A cargo-only flight later in the year to test the spacecraft's propulsion system fixes, or moving forward with certifying Starliner for crewed missions, despite the incomplete crewed test flight last year. It seems nobody really knows what cosmic-level motivation convinced NASA to rescue the Starliner project. Honestly, it's starting to feel like they're just strapping dollar bills to a rocket and launching them into orbit. Because let's face it, Boeing's current situation isn't exactly shooting for the stars. You know, Boeing has already set another shameful record in its history of financial losses, with losses topping $2 billion as of early 2025. These losses stem from years of development issues, including technical problems during test flights and delays in achieving certification for operational use. Risk remains that we may record additional losses in future periods, Boeing wrote in a quarterly filing with the Securities and Exchange Commission. Holy cow! A $2 billion loss on a single program in an area that is not their financial juggernaut. It's equivalent to 1/6 of Boeing's total loss in 2024. Bear in mind, they've only flown that vehicle once with Crew, despite initially getting 2 times more money than SpaceX. Not really a flex you think this is. In 2014, NASA selected Boeing and SpaceX to create commercial spacecraft for transporting crews to the International Space Station. Boeing's contract, similar to SpaceX's, is a fixed-price agreement, now valued at $4.6 billion, compared to a $2.6 billion contract with SpaceX. It means Boeing is responsible for covering any expenses exceeding NASA's agreed-upon funding. So, if both NASA and Boeing want to keep the failing Starliner program alive, I'm curious who their sugar daddy will be. In addition to an initial $4.2 billion contract in 2014, Boeing has received another $400 million under contract modifications since 2014. So far, $2.7 billion has been paid out, while $1.9 billion remains to cover the payment for 6 crew rotation flights once Starliner is certified. Do you think the $1.9 billion is the main reason Boeing is continuing the program? Don't forget to comment yes or no in the comment section below. Assume the tide turned and Boeing's troubled spacecraft is certified, but what does that mean when the ISS is due to be retired sometime in the 2030s? Elon Musk also posted on X last November, "There is no logical purpose to Starliner, given that NASA plans to deorbit space station in roughly 5 years." Meanwhile, NASA has extended SpaceX's commercial crew contract, initially for 6 crew rotation flights, due to delays with Boeing's Starliner. This extension includes the Crew 7, Crew 8, and Crew 9 missions, bringing SpaceX's total commercial crew transportation capability contract to $3.49 billion. In August 2022, NASA further extended the contract to include 5 additional missions, bringing the total contract value to nearly $5 billion for 14 fully operational astronaut launches. SpaceX completed its original commercial crew contract in 2023 and is now working on the extension. NASA anticipates needing additional SpaceX flights as early as 2026 to ensure redundancy, maintain safe space station operations, and and allow both companies to gain operational experience. NASA's assessment is that SpaceX is currently the only certified provider to maintain crewed flights to the ISS while ensuring redundant capabilities through 2030. The extensions cement a long future for SpaceX and NASA as they work together to launch astronauts to and from the International Space Station. It also means the opportunity for Boeing has been decreasing. In response to tons of issues, Boeing has decided to conduct a leadership shakeup one more time. Specifically, Mark Nappi, who held the top job on the Starliner program since 2022, is currently in a new role focused on identifying opportunities for streamlining improvement across the division's space programs until he retires next month. He is in a new role until he retires in February. John Mulholland replaces Nappi to take over as Starliner program manager. He previously led Boeing's Starliner program from 2011 before switching in 2020 to the company's International Space Station program, which works closely with NASA under a multi-billion-dollar station operations contract. This shift occurred after Starliner's initial orbital test flight in 2019, which was unmanned and cut short due to software problems. Nevertheless, it's worth noting that under John Mulholland's leadership of the Starliner program, from 2011 to 2020, key design decisions were made that contributed to significant issues. These included software problems that prevented the spacecraft from reaching the space station during the 2019 test flight. Additionally, the choice of valves susceptible to corrosion in the service module and the discovery of a design flaw in Starliner's parachutes, along with the installation of flammable tape inside the capsule's cockpit shortly before the crew test flight attempt in 2023, further compounded the challenges. More recently, in May 2024, Boeing and NASA discovered a design vulnerability in how the Starliner capsule's propulsion systems are used to return to Earth. This change is part of a broader leadership transition at Boeing. On March 26, 2024, Boeing announced that CEO Dave Calhoun would step down at the end of the year. Boeing has appointed Robert Kelly Ortberg, a seasoned aerospace executive from outside the company, as its new CEO, effective August 8th. He succeeds Dave Calhoun as the company grapples with safety and manufacturing challenges. Ortberg previously led Rockwell Collins, later Collins Aerospace, after being acquired by United Technologies, and oversaw significant acquisitions. Collins Aerospace is now part of RTX, where Ortberg recently served on the board before resigning. As a 35-year aerospace veteran and outsider, Ortberg is expected to bring a steady hand to the struggling company. Jefferies analyst Sheila Kayoglu noted that during his time at Collins Aerospace, Ortberg was known as a tough negotiator, dealing with a diverse set of customers and suppliers, and managing the complexity of its diverse customer base, including Boeing. Ortberg, who has a mechanical engineering degree, will face challenges such as persistent losses, increased regulatory scrutiny, supply chain issues, strained relationships with airline customers due to aircraft delays, cost overruns in the defense unit, and tense labor negotiations. Ortberg said, "I'm extremely honored and humbled to join this iconic company. There is much work to be done, and I'm looking forward to getting started." Ortberg added, "Boeing has a tremendous and rich history as a leader and pioneer in our industry, and I'm committed to working together with the more than 170,000 dedicated employees of the company to continue that tradition, with safety and quality at the forefront." He will be based in the Seattle area, near Boeing's aircraft production facilities, signaling a hands-on approach. His compensation includes a $1.5 million annual base salary, with potential incentives for the following year totaling $20.5 million. For this year, he will receive $1.25 million in cash and other compensation valued at $16 million. Boeing has waived its mandatory retirement age of 65 for Ortberg, as they previously did for Calhoun. Breaking news. Boeing warns employees working on the SLS program that up to 400 of them could lose their jobs as the new administration considers canceling the program. Specifically, in the announcement on February 7th, Boeing SLS employees were informed that the company was making preparations to cut up to 400 jobs from the program because of revisions to the Artemis program and cost expectations. The specific positions being considered for elimination were not announced, but would account for a significant fraction of the overall SLS workforce at the company. Job cuts may occur in April 2025. David Dutcher, Boeing's vice president and program manager for the SLS rocket, added that Boeing's contracts for the rocket could end in March. To be honest, the controversy surrounding the Artemis program and the SLS, a key element of the program, has been around for a long time. In the last November, Ars Technica space journalist Eric Berger, who has deep sources in the space industry, revealed, "To be clear, we are far from anything being settled, but based on what I'm hearing, it seems at least 50-50 that NASA's Space Launch System rocket will be canceled. Not Block 1B, not Block 2. All of it. There are other ways to get Orion to the moon." Elon Musk, founder of SpaceX and head of the Department of Government Efficiency in the Trump administration, has criticized Artemis's current approach, stating in December that it was a jobs-maximizing program, not a results-maximizing program, and that something entirely new is needed. Meanwhile, he continues to advocate for Mars exploration, even calling the moon a distraction. He emphasized his desire for SpaceX to help lead the charge for human exploration on Mars, in large part by using the company's Starship rocket. Following the sixth launch of the rocket in November, he posted to his social media site, X, "I am highly confident that we can send several uncrewed starships to Mars in 2 years. If those ships don't increment the crater count on Mars, then crewed ships can be sent in 4 years." The discussion around Mars also gained increased attention when President Donald Trump said during his inauguration speech that the U.S. will pursue our manifest destiny into the stars, launching American astronauts to plant the stars and stripes on the planet Mars.
"We will pursue our manifest destiny into the stars, launching American astronauts to plant the stars and stripes on the planet Mars."
In addition, critics argue that NASA should discontinue the Space Launch System program due to its high costs, with each launch exceeding $2 billion, not including payload or ground system expenses. NASA has been spending around $3 billion annually on the SLS and its ground systems. These critics suggest that maintaining the SLS for lunar landings would hinder progress, because contractors like Boeing, benefiting from cost-plus contracts, would be encouraged to prolong the work to secure continued funding. Thanks to its footprint since the dawn of space exploration, Boeing won the core stage SLS contract with ease based on its prior contract for Constellation. However, what they showed was very shameful. We did notice very poor contractor performance on Boeing's part. There's poor planning and poor execution, NASA Inspector General Paul Martin said. "We saw that the cost-plus contracts that NASA had been using worked to the contractors rather than NASA's advantage." An Inspector General report in 2018 projected the core stage cost would increase to at least $8.9 billion through 2021, more than double the initial projection of $4.2 billion in June 2014. NASA estimated a single SLS Block 1B is estimated to cost at least $2.5 billion to produce, excluding systems engineering and integration costs. As a result, the price tag of the SLS program in general has ballooned to $23 billion by 2022, 3 times an initial $6.2 billion by 2018. Simultaneously, the SLS rocket ended up flying its first launch in Artemis, more than 6 years later than originally intended. Following that, the next Artemis missions are also getting delayed. On the other hand, NASA and its contractor involved in the Artemis lunar exploration campaign have urged the new administration to keep the current architecture, arguing that it still provides the fastest way to return humans to the moon. This partly stems from the fact that SLS is the only rocket capable of carrying humans from Earth to lunar space. It offers high escape velocities to send more mass to deep space destinations and can reduce transit time. Therefore, abandoning SLS could leave the United States behind other countries, such as China, in the race to the moon. Lockheed Martin's Kirk Shireman urges his workforce to stay focused despite potential changes with the new administration. At least every 4 years, or likely every 4 years, an administration changes, and there's uncertainty, Shireman said. The best thing we can do is keep your head down and work as hard as you can, and do the things that our nation tasked us to do. Acting Administrator Janet Petro has urged the White House to allow NASA to fly the Artemis II and Artemis III missions, using an early version of the SLS rocket before the program is canceled. As the controversy intensified, Eric Berger reported in December that the likelihood of canceling the SLS had shifted from a 50-50 chance to a 75-25 probability in favor of cancellation. Such a good news. At present, NASA has not announced any revisions to the Artemis program, and a panel of NASA. The Trump administration has also not made any public changes to Artemis since taking office on January 20th. Industry officials are pressing ahead with preparations for the Artemis II mission, the first crewed SLS Orion flight, scheduled for April 2026. NASA pushed back the date of that mission multiple times, mainly due to questions about the readiness of the Orion spacecraft's heat shield, which experienced unexpected char loss during the Artemis I mission. NASA ultimately determined that gases were able to build up within the ablative outer layer, called avcoat, which were not able to vent and dissipate as expected. Matt Ramsey, Artemis II mission manager at NASA, said on January 29th, "The agency has challenged us to do better, and we're in the process of figuring out what better looks like," he said, with a Work to launch date coming in the next few weeks. There are also the routine issues that occur daily on the program, Ramsey added. There's a whack-a-mole every day where we find problems, fix problems, and move on to the next day. With the heat shield issue resolved, he said the key factors driving the launch date will be work assembling the vehicle. Crews are currently stacking segments of the SLS's twin solid rocket boosters, a process that should be complete in the next 2 to 3 weeks, said Brad McCain, Deputy Program Manager for Ground Operations at Amentum. Once the vehicle is fully assembled, it will be rolled out to Launch Complex 39B for a tanking test. The schedule for that tanking test is a little bit variable, said Charlie Blackwell Thompson, NASA Artemis Launch Director, but would be no earlier than the fall. Beyond Artemis II, NASA is also looking into the future of the Artemis program, starting with Artemis IV. NASA plans to use the Block 1B version of the SLS rocket, which requires a new mobile launcher and Boeing's Exploration Upper Stage EUS. The flight-worthy EUS is expected to arrive at Stennis Space Center in Mississippi in late 2026 for testing, including hot fire tests, either late that year or in early 2027. John Shannon, the Vice President of Boeing Exploration Systems, said, "What you'll see roll out first is the structural test article, which looks just like the EUS. We'll take it to Marshall Space Flight Center and do all the mean things that we did to all the other elements and put it through its paces," Shannon said. "And then we'll go to Stennis and do the green run." Unlike the Artemis I core stage green run, this go-around they will do a couple of firings on purpose this time and will end up swapping out engines. Those engines will not be vacuum-rated engines. They'll be sea-level rated engines, Shannon explained. We'll swap out the engines and then send it off to the Cape for the Artemis 4 flight. Assuming a launch of the Artemis 2 mission in April 2026, it would be a roughly 14 to 16-month turnaround before the planned launch of Artemis 3 in 2027, mid-2027. Production on the heat shield blocks began in October 2024, and for its part, Amentum, the company responsible for integrating the pieces of the SLS rocket and going through checkouts as part of NASA's Consolidated Operations, Management, Engineering, and Test contract, is working to establish the ability to move through a launch campaign as quickly and efficiently as possible. As far as a timeline, we would hope to do better than 14 months. To be quite honest, you really can't use Artemis 1's timeline as a baseline because of so many different things that we did, and the unexpected damage and everything we fixed for Artemis 2. That delayed everything getting started, Brad McCain, the deputy program manager for Amentum, said. If the hardware performs as it should, and we get what I would call the expected response from the infrastructure, then 14 months is sufficient time to turn around. I think the target is 12 to 13 months. Yeah, 12 months nominal. We actually have Artemis 5 and parts of 6 in manufacture at the Michoud Assembly Facility in New Orleans, Lockheed Martin's Kirk Shireman added. We are processing and building multiple vehicles right now, and some of the things that we're focused on now is how do we accelerate the pace at which we can build and test this vehicle and get ready to fly. It really is a big focus for us. Anyway, frankly, it's honestly unclear where Artemis and SLS are headed. We just know that efforts to cancel the SLS or significantly alter the Artemis program structure are similar to a situation that occurred in 2010 when the Obama administration tried to end the Constellation program, which ultimately led to the creation of the SLS. The ripple effect of canceling SLS is already here. Boeing just gave 400 employees an unexpected promotion to full-time Netflix reviewers. This reflects the balance between representative democracy and potential bias towards wealthy industries. Nevertheless, anything could change during Trump's second term with the role of Elon Musk in the Department of Government Efficiency. So, how about you? Either cancel SLS or keep it. If you were in Congress, which one is your option? Let me know in the comment section below. On January 16th, SpaceX launched its 7th Starship rocket on a test flight that didn't go nearly as far as many had hoped. So, what's the progress on Starship Flight 8? And what does SpaceX aim for in the upcoming launch? Starship Flight 8 will see the use of Booster 15 and Ship 34. The second Block 2 ship-readied for launch. The two have had their main structures already assembled and have both undergone cryogenic proof tests on their tanks. They then were back at the assembly site getting Raptor engines installed, flaps, and other final components added on. More notably, on February 9th, Booster 15 experienced a successful full-duration static fire test, 24 days after Flight 7. Afterward, it's expected to roll back for checks before rolling out once again ahead of launch. Ship 34 might follow soon. The vehicle is on the static fire stand and on its way to Massey's for its engine tests. Test Tank 16 was moved from the Star Factory to Massey's test site for upcoming structural testing. The movement of Test Tank 16 to Massey's aligns with SpaceX's ongoing development and testing of Starship hardware, reflecting the company's continuous efforts to refine and test their rocket technology. Once these steps are completed, SpaceX will need additional time to fully stack both stages, conduct the final testing campaign, and finalize the installation, including the Flight Termination System, FTS. Meanwhile, the usual pre-testing operations are in Pad B. The chopsticks have opened and raised to the launch position, and the Ship Quick Disconnect arm that connects to the rocket for loading propellants tested its capability to swing back to clear the rocket for launch. Given the current pace of progress, the end of February target still appears feasible. While SpaceX has not yet announced any official launch date, there is news that the firm has applied to the FCC for communications license for Starship Flight 8 with a start date of February 24, 2025. It means Starship Test Flight 8 launch will be no earlier than February 24th. To meet that date, SpaceX has to overcome the hardest part, FAA's approval, which follows the completion of the Flight 7 accident investigation. SpaceX will first have to submit its mishap investigation results to the FAA before it can gain approval for another flight. Following the Starship Flight 7 failure, the Federal Aviation Administration, FAA, initiated a debris response area, briefly restricting airspace near Turks and Caicos. This action, along with flight diversions, caused travel delays. Debris from the failed launch has been discovered across the islands. The Turks and Caicos Reef Fund, in collaboration with the government, has compiled a database documenting the wreckage found on every beach of Providenciales and spanning the Caicos banks. There is a report of property damage, with debris possibly hitting a vehicle in South Caicos, although the FAA has only confirmed one report of minor damage to a vehicle. The FAA requires SpaceX to maintain liability insurance for such claims, but it's rare for debris from U.S. rockets to cause damage, and there are no known public records of third-party property damage claims in commercial spaceflight. Authorities in Turks and Caicos met with SpaceX representatives and the UK's Air Accidents Investigation Branch to plan debris recovery. While this could further delay SpaceX's timelines, I bet that Elon Musk's rocket company will do its best to turn the thing around. This is important because they are looking at 25 Starship launches this year, including a goal of catching up with the Starship upper stage by 2025, allowing for 100% rocket recovery. To move closer to catching Starship in the future, Flight 8 needs to successfully complete the objectives that Flight 7 couldn't. Flight 7 partially succeeded by catching the booster, making future catches more probable. However, the Block 2 ship design validation was incomplete due to the upper stage's failure. This leads to the incompletion of the deployment of its first satellites in space and several heat shield tests, including new tile designs and missing tiles, to stress test it during re-entry. Consequently, Flight 8 will likely repeat Flight 7's mission, including heat shield testing and deploying dummy Starlink satellites. This means Flight 8 will likely be another suborbital flight with a splashdown in the Indian Ocean. If that's true, on Flight 8, SpaceX will deploy 10 Mach satellites, similar in size and weight to next-generation Starlink satellites, Starlink version 3. This would have been the first ever payload deployment for Starship. These Mach satellites will not remain in orbit and will splash down in the Indian Ocean after their suborbital flight. SpaceX would begin launching Starlink version 3 satellites before they were catching and reusing Starships. SpaceX's third-generation Starlink satellites are a major advancement in their internet service. Each satellite is designed for significantly higher data transmission rates, with the ability to download 1 terabit of data per second and upload 160 gigabits per second. These satellites are much larger and heavier than previous versions, weighing approximately 1,900 kilograms. They will be launched using the Starship rocket, with each launch potentially adding a substantial amount of capacity to the Starlink network. The third-generation satellites incorporate advanced technologies for computing, modems, and data routing. They are designed to achieve low latency, meaning minimal delays in data transmission, by operating in a lower Earth orbit. These satellites also feature increased capacity for data transfer between satellites, which is essential for a robust network. SpaceX offers a third-generation Starlink standard kit, which includes the necessary equipment for connecting to the satellite internet service. The kit includes cables, a router, a dish, and a power supply. The Starlink service provides download speeds of up to 250 megabits per second. The router uses Wi-Fi 6 technology to efficiently cover a large area and support many connected devices. SpaceX plans to begin deploying these third-generation Starlink satellites in the near future. It's important to have a clear view of the sky to connect to the satellite network. Please note that using a Starlink kit outside its original sales region may incur extra fees. SpaceX has requested permission from the Federal Communications Commission to deploy nearly 30,000 of these satellites. For the heat shield testing, S-33's heat shield used the latest generation tiles and included a backup layer to protect from missing or damaged tiles. Starship's heat shield is the biggest gating item in SpaceX's goal of rapid and reliable rocket reusability. In addition to new ceramic tiles, SpaceX will likely test a few metal heat tiles, including one with active cooling, on Flight 8 as it continues searching for the right heat shielding solution. There were rumors that Flight 8 could see the first orbital flight and ship catch attempts, but that is unlikely given Starship Block 2's first launch failure. While this may prolong the journey to full reuse, it is better to be safe than sorry. SpaceX has to commit to its principle of safety, especially when the company is taking responsibility for Artemis 3, the first crewed lunar landing since Apollo 17 in December 1972. So, how about you? Do you agree with the idea of repeating Flight 7's goal in Flight 8? Don't hesitate to drop the heart icon in the comment section below if you agree. SpaceX's Starship plays a crucial role in NASA's Artemis 3 mission. As part of NASA's Artemis program, SpaceX is developing a modified version of its Starship spacecraft, known as the Human Landing System, HLS, to transport astronauts from lunar orbit to the Moon's surface and back. NASA formally entered the picture in 2021, awarding SpaceX a $2.89 billion contract, making Starship a cornerstone of the Artemis 3 mission. A further $1.15 billion contract modification in 2022 added a second crewed landing for Artemis 4. The Artemis 3 mission involves multiple spacecraft and advanced technologies. The mission is intended to land a woman and a person of color on the Moon. The crew will launch aboard NASA's Orion spacecraft using the Space Launch System rocket to travel to lunar orbit. Separately, the Starship HLS will launch from Earth using SpaceX's Super Heavy booster, a reusable rocket powered by 33 Raptor engines. The Starship HLS will then enter lunar orbit and dock with the Orion spacecraft. 2 Artemis crew members will transfer from Orion to Starship and descend to the lunar surface. The 2 astronauts will conduct up to 4 spacewalks on the Moon, performing scientific observations and collecting samples, including water ice. After about a week on the lunar surface, the astronauts will return to the Orion spacecraft in Starship. SpaceX's Starship HLS presents several innovative features. Refueling operations are planned to occur in Earth orbit to fully fuel the Starship for its journey to the Moon. The Starship HLS will give the astronauts a special ride en route to the Moon and back to the Orion spacecraft. Prior to the crewed Artemis 3 mission, SpaceX will perform an uncrewed landing demonstration mission on the Moon. NASA is providing SpaceX with specific requirements to prepare Starship for the Artemis 3 mission, drawing upon the agency's extensive experience in human spaceflight. SpaceX has pledged to share its data from Starship flight tests with NASA to refine the design for Artemis 3 and help NASA manage risks and mature its landing tasks. NASA is also working with SpaceX to further develop the Starship lander to meet an extended set of requirements for Artemis 4, including landing more mass on the Moon and docking with the agency's Gateway Lunar Space Station for crew transfer. As of December 2024, NASA anticipates that Artemis 3 will launch no earlier than mid-2027 due to heat shield issues on Orion and valve problems in the spacecraft's life support system. In August 2023, NASA officials expressed a willingness to fly Artemis 3 without a crewed landing due to delays in Starship's development, potentially turning the mission into a crewed visit to the Lunar Gateway. In April 2024, NASA was internally evaluating alternative mission options, including a docking test between Orion and Starship HLS in low Earth orbit. In conclusion, it would be exciting to see SpaceX gradually perfecting its Starship program to serve the long-term goal of space exploration. Wishing them all the best on Flight 8. By the way, let's send your best wishes to the company by commenting on this video. Thanks for watching till the end. During Starship Flight 7, SpaceX introduced the world to the second generation of Starship, namely Ship 33, a more powerful and advanced version. Although the vehicle exploded sooner than expected after launch, the data during that short-minute flight is very valuable for SpaceX to upgrade its next prototypes. Now, Flight 8's hardware, including Ship 34 and Booster 15, has partly finished the key tests toward the launch. Booster 15 completed its static fire test on February 9th, then rolled to Mega Bay 1 for flight readiness upgrades. Ship 34 followed Booster 15 by firing for nearly a full minute at Massey's during its static fire test on February 11th. The tests seem to go smoothly, and we hope that in its real flight the vehicle will achieve the goals that its unfortunate predecessor failed to achieve. As SpaceX is on its way to perfecting its next-generation design for the ship, one question is blooming. How about the Super Heavy? When will the Block 2 booster come online? Well, it could make its debut this year. Online speculation suggests that Booster 17 might be the final Block 1. If this is the case, it might not be used for flight, as the last in a series of Starship designs often doesn't get the opportunity to fly. If SpaceX halts booster production, they could continue using the existing version 1 hardware until Block 2 is ready, especially since they've successfully caught the Super Heavy twice. In fact, there are signs that SpaceX is moving toward a Block 2 booster. The Test Tank 16, which is theorized to be a Block 2 booster test tank, was moving back and forth between Massey and Star Factory. It likely seems to have had some work done, including some modification following S-33's anomaly in flight. Meanwhile, so-called the final Block 1 booster, B-17, has recently caught our eye as its components such as the aft section and downcomer or transfer tube were seen in Mega Bay 1. This suggests that B-17 may be nearing completion. With all said, I bet that the date the booster Block 2 comes online is no longer further. So, which prototype would become the Block 2? All of us hope the answer is B-18. If B-18 is indeed the first Super Heavy version 2, it is reasonable to expect a launch in Flight 10. The countdown to Super Heavy version 2 is on, and the excitement is palpable. Show your excitement for this new booster by commenting Full Version 2. Also, like and subscribe to our channel to stay updated on the innovative progress of the spaceflight. When all's said and done, the next iteration of SpaceX's Super Heavy booster, known as Version 2, promises significant improvements that will elevate its capabilities to remarkable new heights. Since Elon Musk stated that Super Heavy version 2 would be taller and feature big improvements, the Block 2 second stages are planned to be 1.3 meters taller than the previous Block 1 vehicle, making it 72.3 meters long and allowing for a greater fuel capacity. Apparently, to carry up a heavier object, it will need more powerful engines, and this is where SpaceX's revolutionary Raptor 3 engines come in. Earlier last year, SpaceX introduced the Raptor 3, showcasing its sleek black design and simplified structure, which not only reduces the potential for risks, but also makes the engine easier and faster to refurbish, a key factor in achieving rapid reusability. The streamlined manufacturing process will allow SpaceX to produce engines more efficiently, meeting the increasing demand for Starship launches. The Raptor 3 engine achieves a thrust of 280 tons force, a notable increase from Raptor 2's 230 tons force, and Raptor 1's 180 tons force, 185 tons force. Elon Musk has indicated the potential for Raptor 3 to exceed 300 tons of thrust in future iterations. A group of Raptor 3 will certainly provide 8,240 tons force of booster liftoff thrust, significantly higher than 7,130 tons force of booster version 1. To put this into perspective, this level of power is 2.3 times greater than that of the Saturn V, the rocket that once carried astronauts to the moon. Such extraordinary thrust levels will enable Starship to carry out more than 100 tons of payload to orbit. Beyond engine upgrades, Super Heavy version 2 will feature several improvements to boost performance and reliability. The grid fins will be moved lower to enhance stability, addressing issues from prior launches. Specifically, during Flight 7's test, Booster 14's grid fins showed warping, likely from extreme heat exposure caused by the hot staging technique, where Starship engines ignite while still connected to the booster. Camera footage showed flames impacting the grid fins, which could compromise flight safety and performance, an issue also seen in Flight 5. A potential solution could be lowering the grid fins to avoid the thermal impact. In addition to the change in the grid fin's position, the hot staging system will be redesigned with a longer ring and larger vents to simplify the design and improve stage separation efficiency. This new hot staging ring is also expected to be reusable, which aligns with SpaceX's goals of cost reduction and waste minimization. Along with Booster version 2, can't help but mention its partner, the Upper Stage version 2. Elon Musk highlighted features of the new generation, stating, "Version 2 of the ship holds more propellant, reduces dry mass, and improves reliability. Future Starships might retain 6 Raptor engines, and the spacecraft's size may increase by 1.8 meters, resulting in 52.1 meters. When paired with the taller Block 2 low stage, the complete Starship system will reach an astonishing height of 124.4 meters, making it an even more formidable spacecraft. This additional space will enable it to carry up significantly more fuel. This increase in fuel capacity is critical to supporting the enhanced performance required for future missions, for example, in NASA's Artemis 3 mission. Under Artemis 3 scheduled in mid-2027, Starship HLS needs multiple tankers for refueling in orbit, because the amount of fuel required to reach the Moon from low Earth orbit is large, and a single tanker wouldn't be able to carry enough propellant to fully refuel the lander. In this case, HLS could be version 1, meanwhile those tankers could be version 2. Who knows? Do you have any objections at this point? Don't hesitate to share your thoughts. For the ship, a stretched payload area could increase the payload volume from 1,000 cubic meters to a range of 1,400 to 1,800 cubic meters. Remaining the engine count at 6, but with greater thrust, should enhance the spaceship's initial propulsion up to 1,600 tons force, enabling it to launch more payload into orbit. The second-generation Starship will also feature upgrades based on lessons learned from previous integrated flight tests and ground tests prior to launch. Expect improved and more secure welds in future Starship variants, with the possibility of Super Heavy rockets also receiving these design upgrades in the future. Starship version 2 will feature significant changes up and down the spacecraft, taking lessons from previous flight tests to improve reliability and performance. SpaceX has implemented hardware changes on upcoming Starship vehicles to improve leak reduction, fire protection, and refined operations. To align with those upgrades, SpaceX is enhancing its infrastructure, with reports indicating that the new launch tower, while keeping the same segment count, will be slightly taller to fit Starship version 2's increased height. This ensures full compatibility with the enhanced booster and spacecraft. Starship version 2 marks a key step toward SpaceX's long-term goals, including catching the entire Starship system with the Mechazilla arm. Success would be a spaceflight milestone, enabling full spacecraft reusability, revolutionizing space exploration, cutting costs, and allowing more frequent, ambitious missions. Despite remaining work, SpaceX's progress is clear. The Starship version 2 is set to raise rocket performance benchmarks, showing the company's innovation drive. Each upgrade brings Starship closer to its potential as the workhorse of future space exploration, with the years ahead promising excitement as SpaceX refines its technology and pushes space travel boundaries. The journey to a fully reusable next-generation spacecraft is underway, with Starship's next generations playing a central role. Following the Block 2, we have Block 3. The timeline to produce SpaceX's Starship Block 3 depends on the success of the Block 2 tests and the availability of the Raptor 3 engines. If significant lessons are learned from the Block 2 tests, adjustments might be made to the design or construction timeline of Block 3. Honestly, it might come soon. A critical enhancement in Block 3 will be its cryogenic fluid management systems, essential for effective orbital refueling. This capability is vital for supporting NASA's objectives, particularly for lunar missions under the Artemis program. NASA's HLS program manager hopes for a ship-to-ship demonstration to occur this year, ahead of Artemis 3 scheduled for 2027. For this reason, it is very likely that SpaceX will accelerate Block 3 production and testing as soon as possible to meet NASA's requirements. So let's guess when Block 3 will start to be built. SpaceX is developing Starship, a fully reusable transportation system, with the aim of reducing spaceflight costs and enabling the colonization of Mars. Starship is designed to transport both crew and cargo to Earth orbit, the Moon, Mars, and beyond. Elon Musk envisions Starship facilitating long-duration journeys to Mars and back. SpaceX aims to lower launch costs through economies of scale by reusing both rocket stages, increasing payload mass to orbit, increasing launch frequency, and mass manufacturing the rockets. SpaceX aims to reduce spaceflight costs enough to make the colonization of Mars feasible. Starship is intended for interplanetary travel, making material selection a significant factor in reaching Mars. Starship is designed to transport both crew, up to 100 people, and cargo to various destinations, including Earth orbit, the Moon, and Mars. Starship is also capable of point-to-point transport on Earth, enabling travel to anywhere in the world in 1 hour or less. It will be used to refuel other Starship spacecraft, enabling them to reach higher orbits and other space destinations. SpaceX is providing the lunar lander that will return astronauts to the Moon's surface under NASA's Artemis missions. Starship could be employed to deploy space telescopes and launch thousands of satellites swiftly. Starship has also been designed to transport heavy materials essential for constructing space stations and developing infrastructure for human habitation on the Moon. To build a successor to the dying International Space Station, 6 other companies and SpaceX collaborated with NASA through an unfunded Space Act agreement called the Collaborations for Commercial Space Capabilities 2 Initiative, CCSC-2. In this agreement, SpaceX proposes using its own interplanetary spacecraft as a space station. On NASA's site, they wrote, SpaceX is collaborating with NASA on an integrated low-Earth orbit architecture to provide a growing portfolio of technology with near-term Dragon evolution and concurrent Starship development. This architecture includes Starship as a transportation and in-space low-Earth orbit destination element, supported by Super Heavy, Dragon, and Starlink, as well as constituent capabilities including crew and cargo transportation, communications, and operational and ground support. The question now is Starship suitable as a space station? This was also the question posed to the SpaceX founder at the International Astronautical Congress in 2023, to which Elon replied, "The volume of the Starship fairing is comparable to the volume of the International Space Station. About 1,000 cubic meters of volume in the fairing. You could do what you are doing on the space station on a Starship if you want. There's no limit to how long it can stay up there. It really just, you need solar panels, battery, and thrusters to maintain orbit. Come to think of it, this makes a lot of sense. Starship is already the vehicle built for long-term space travel. It's already a mobile habitat. All we need to do is make it more comfortable and install the necessary facilities to turn it into a space station. Now there are two designs for the Starship space station layout: vertical and horizontal division. In vertical layout, the ship will be divided into 6 distinct floors, each serving a vital purpose for long-term space missions. The first floor will house the warehouse, dedicated to storing food, equipment, and other essential supplies. This floor will also contain life support systems and power generators, ensuring the ship's functionality and crew safety. On the second floor, a plant-growing facility will provide a sustainable source of fresh food. Long-term space travelers will quickly grow weary of vacuum-sealed meals, and fresh produce will help maintain vital nutrients that degrade over time. The third floor will feature a state-of-the-art gym, essential for maintaining the crew's physical health in low-gravity environments. Exercise is critical to prevent muscle atrophy and bone loss during extended space missions. The fourth floor will be designated for crew quarters, offering private spaces where crew members can rest and recharge between their duties. On the fifth floor will be a laboratory where zero-gravity experiments will be performed. The sixth floor, being closest to the nose cone of the ship, will be limited in space. This floor will serve as a multifunctional area for meetings, or simply as an entry point to get into the station. These floors will be connected to each other via a central elevator. With horizontal arrangement, the number and layout of the areas will remain the same, the difference being that a single floor will be installed that runs throughout the station and eliminates the need for a central elevator. To further utilize the space of the Starship, after entering orbit, we can utilize the empty fuel tank to refurbish it into a living area or warehouse. Fortunately, since Starship is made primarily of steel, refurbishing the ship in space doesn't pose too many challenges. But that's not all that's exciting about the Starship space station. SpaceX and NASA plan to transform it into a Von Braun wheel, a rotating wheel space station. This is a hypothetical design for a space station shaped like a wheel that spins to create artificial gravity by utilizing centrifugal force, essentially simulating the feeling of gravity on the outer rim of the wheel. Even if the space station provides us with enough oxygen, food, and water to survive, our bodies still suffer the consequences of living for long periods in a zero-gravity environment. Humans are optimally adapted to Earth's surface conditions, and when exposed to weightlessness, various physiological systems undergo changes, with some even experiencing atrophy. While these effects are typically temporary, some can have lasting consequences on human health. Therefore, centrifugal gravity will be essential if we want to create an environment that supports long-term survival in space. To create such a space station, not just one, but dozens of starships would be connected together in space to form the outer ring of the Von Braun wheel. It sounds like a lot, but given the cost of a starship, such a massive space station would be even cheaper than our own International Space Station. Do you know what that means? This means that commercial travel to the International Space Station will be possible. Not only that, but the space will be so large, and the cost of each flight will be so cheap that even ordinary people like us will be able to hang out on SpaceX's space station one day. At the same time, centrifugal gravity will simultaneously protect these unsuspecting tourists from the perils of zero gravity and spare them the dreaded experience of microgravity toilets. While this is a great idea, SpaceX is currently facing its own challenges. Before they can build a space station out of Starship, they need to first focus on perfecting the vehicle. In the meantime, let's look at other rival space stations. Sierra Space recently made a major step forward in its space station development. In November 2024, Sierra Space proudly announced the successful completion of its 6th stress test and 4th ultimate burst pressure (UBP) test for the Life 10 commercial space station technology. This milestone marks the final UBP test required to meet factor of safety recommendations, paving the way for certifying the revolutionary, expandable Life platform, large integrated, flexible environment for human habitation. The Life 10 in the latest test, conducted on October 29th at NASA's Marshall Space Flight Center, ruptured at a record-breaking pressure of 255 psi, the highest recorded pressure in the 3-year restraint layer certification campaign. This failure point exceeds all NASA guidelines for restraint layer capabilities across various applications and environments. As a standalone product, the Life 10 restraint layer demonstrated its ability to surpass NASA's 4 times factor of safety recommendation for both low Earth orbit and lunar environments. With an internal volume comparable to a 10-foot-long moving truck, Life 10 proves to be an ideal module for lunar surface missions. In a low Earth orbit environment, where the module's internal pressure is approximately 15.2 pounds per square inch, similar to Earth's atmosphere, the Life 10 boasts an outstanding factor of safety, greater than 16 times. In contrast, within the lunar environment, where operational requirements result in a reduced internal pressure of around 10.8 pounds per square inch, Life 10's restraint layer achieves a remarkable 23 times factor of safety. These impressive safety margins reinforce Sierra Space's leadership in commercial space station development as it successfully concludes the UBP phase of the Life 10 test campaign. Former Sierra Space CEO Tom Weiss said, "Our company is fully committed to developing the necessary technology to ensure there is no gap in LEO when the International Space Station is decommissioned. We are leading the industry in the development of revolutionary expandable structures that will bring to life the world's first end-to-end business and technology platform in low Earth orbit, enabling humanity to find the answers to some of the toughest problems faced on Earth." With this achievement, Sierra Space's commercial space station technology is advancing rapidly towards certification. Unfortunately, Orbital Reef's completion doesn't depend solely on developments from Sierra Space. The most recent progress Blue Origin achieved on this space station was announced by NASA a year ago when they completed 4 milestones set by the government agency. There hasn't been much else from Blue since then. Will Orbital Reef be completed before 2030? This is something we will have to wait and see. Another rival of SpaceX's space station, Axiom Space, recently released a new plan that it believes will speed up the completion of its space station. The company revealed an updated timeline for deploying modules to construct its Axiom station by the end of the decade. The first step will involve installing a Payload Power Thermal Module, PPTM, on the ISS. Axiom initially planned to install a Habitat module on the ISS in late 2026, followed by a second Habitat module and a research module. Finally, a power and thermal module with plans for those modules to eventually undock and become a free-flying station. However, Axiom executives noted that these modules were slated for the Node 2 forward docking port, which will later be used by the U.S. Deorbit Vehicle, USDV, for the station's final deorbit maneuvers. So the company has revised the assembly sequence, starting with the PPTM, which includes power, thermal systems, and 8 science racks. Instead of docking the PPTM to Node 2 forward, it will now berth at one of 2 ports currently used by cargo spacecraft, like Cygnus. Axiom would then launch the first Habitat module, HAB-1. Instead of docking it to the ISS as initially planned, the company would have the PPTM detach from the ISS and dock with the new Habitat module. This would create a free-flying station with just 2 modules, capable of supporting a crew of 4. According to Axiom, this milestone could be achieved as early as 2028, ahead of the previously projected timeline. George Motter, chief engineer and architect of Axiom Station, said, "The huge advantage here to both NASA and Axiom is the fact that they do not have to reconfigure the forward port. They can bring the deorbit vehicle at any time. They can prepare for deorbit on their schedule, and once we arrive, we can stay there for a short time or a long time. We're not in the way." Once the station is free-flying, Axiom plans to add an airlock module, a second Habitat module, and a research module. Each module is designed with its own unique power and thermal capabilities. Additionally, the first Habitat module is equipped with a robotic arm, enabling it to reconfigure the station as needed. Mark Greeley, Chief Operating Officer of Axiom Space and Program Manager for Axiom Station, said the revision does not affect the overall cost of Axiom Station, which the company has yet to disclose. It does favorably impact our cash flow needs. It really is just a matter of phasing our cash flow needs to accommodate the new sequence. At this point, there's no certainty that a replacement space station will be ready by the time the ISS is retired. This isn't entirely surprising, considering that it took over $150 billion and more than 22 years to construct the International Space Station. Also, the CLD program was specifically designed to encourage the development of new space stations while minimizing NASA's financial burden. With limited funds available and a tight timeline, all we can do is hope that technological advancements will make possible what once seemed unimaginable just 2 decades ago. Blue Ghost has officially left Earth's orbit. Since launching into orbit aboard SpaceX's Falcon 9 a month ago, on February 8th, Blue Ghost successfully performed a trans-lunar injection burn to escape Earth's gravitational pull and begin a 4-day transit to the Moon's orbit. Firefly shares on X with joy. Blue Ghost has merged onto the highway to the Moon. After a successful trans-lunar injection burn, our lander has left Earth's orbit and begun its 4-day transit to the Moon's orbit. We'll then spend approximately 16 days in lunar orbit before we begin Blue Ghost's descent. This gives us plenty of time to calibrate our navigation system and continue payload science operations for NASA's Blue Ghost Mission 1. Before leaving, the spacecraft captured a final image of Earth. As it was set to operate on the Moon until its batteries ran out, this moment also marked Blue Ghost's last interaction with its home planet. Australia can be seen in the photo. After the trans-lunar injection, Blue Ghost executed a precise trajectory correction maneuver to ensure it remained on course during its journey to the Moon. So far, Blue Ghost has successfully conducted dozens of health tests, generating an impressive 13 gigabytes of data. All 10 NASA payloads aboard are in optimal condition and fully prepared for surface operations on the Moon. One of these payloads is NASA's Radiation-Tolerant Computer, developed by Montana State University. It successfully operated while traversing Earth's Van Allen radiation belts, offering valuable insights into how to mitigate radiation effects on computers. This advancement enhances our understanding of the radiation environment that future astronauts may face during Artemis missions. In another milestone, NASA's Lunar Magnetotelluric Sounder, LMS, developed by the Southwest Research Institute, accurately detected a shift in magnetic fields during an on-orbit health check. This promising result indicates that LMS will be capable of measuring the Moon's magnetic and electrical fields, providing crucial information about the Moon's interior temperature and composition. During another health check, Firefly and NASA teams successfully captured data and an interior image of the sample container from NASA's Lunar Planet Vac, LPV. This confirms that the payload is fully operational ahead of its surface operations on the Moon. The LPV is a technology demonstration designed to efficiently collect and transfer lunar soil from the surface to other science instruments or sample return containers, without relying on gravity. The Firefly's Blue Ghost lander features a robust, box-shaped structural framework supported by 4 sturdy landing legs. It is equipped with 2 decks designed for versatile equipment mounting, offering a total payload capacity of 155 kilograms. Power is supplied by solar panels, which can either be mounted along the spacecraft's sides or deployed to extend above the top deck, allowing for optimal positioning relative to the Sun. The solar arrays generate 450 watts of nominal power, with a peak output of 650 watts. Thermal regulation is achieved through a combination of heat pipes, radiators, multi-layer insulation, and active heaters. Surface communications provide an average downlink speed of 6 megabits per second, with a peak of 10 megabits per second, while uplink speeds average 0.2 kilobits per second, reaching a peak of 2 kilobits per second. This design has proven highly effective, so much so that Blue Ghost was able to skip the third Earth orbit maneuver during the translunar injection. For this reason, NASA trusted it with 2 more missions to return to the Moon in 2026 and 2028. Blue Ghost Mission 2 in 2026 employs a 2-stage spacecraft configuration with Firefly's Blue Ghost lunar lander stacked atop the Elytra Dark Orbital Vehicle. The Elytra vehicle will first deploy Blue Ghost and the European Space Agency's Lunar Pathfinder satellite into lunar orbit. Following deployment, Blue Ghost will land on the far side of the Moon, where it will operate both government and commercial payloads for over 10 days on the lunar surface. The Moon's far side is an ideal destination due to its exceptional quiet environment, free from Earth's radio frequency interference. This unique isolation provides an optimal setting for scientific exploration. Additionally, during the lunar night, the Moon effectively shields against solar noise, creating the perfect conditions to collect critical data on the cosmic dark ages. Then, 2 years after that, Blue Ghost will once again return to the Moon along with Elytra Dark Orbital Vehicle and a rover for the Blue Ghost Mission 3. The landing site for this mission is the Gruithuisen Domes, an intriguing region of ancient lava flows located near Sinus Viscositatis on the Moon's near side. Shrouded in geological mystery, the domes are believed to consist of silica-rich volcanic minerals, which may point to the presence of lunar water and hydrogen. Blue Ghost Mission 3 will be the first to land in the Gruithuisen Domes, providing a unique opportunity to explore the distinctive composition of the Gamma Dome. During mission operations, Elytra will first deploy Blue Ghost into lunar orbit, where it will stay to provide continuous long-haul communications. Blue Ghost will then land in the Gruithuisen Domes, release the rover, and operate 6 NASA-sponsored payloads for over 14 days on the lunar surface. These payloads will investigate the Gamma Dome's unique formation and composition, contributing valuable insights that will guide future robotic and human exploration on the Moon. Additionally, the mission will enhance our understanding of Earth's history and the broader solar system. Speaking of lunar vehicles, did you know the VIPER project is back? That's right, one of the biggest regrets of last year, VIPER has risen from the ashes. VIPER, which stands for Volatiles Investigating Polar Exploration Rover, was a robotic mission designed to land near the Moon's south pole and spend 100 days searching for lunar ice deposits. The mission was canceled last year due to escalating costs, but it looks like it will come back. Recently, NASA has published an announcement for partnership proposals, inviting proposals from parties interested in partnering with NASA to obtain science data with NASA's VIPER by landing it on the Moon, operating it, and sharing the scientific results. Under the terms of the agreement, NASA will provide the existing VIPER rover in its current form. Potential partners will be responsible for integrating the rover, ensuring its successful landing on the Moon, conducting a science and exploration campaign, and distributing the data generated by VIPER's instruments. Partners are prohibited from disassembling the rover or using its components separately from the VIPER mission. NASA's selection process will prioritize proposals that facilitate the open sharing of data from the mission's scientific instruments with anyone interested in using it. Nikki Fox, Associate Administrator in the Science Mission Directorate at NASA headquarters in Washington, said, "Moving forward with a VIPER partnership offers NASA a unique opportunity to engage with the private sector. Such a partnership provides the opportunity for NASA to collect VIPER science that could tell us more about water on the Moon, while advancing commercial lunar landing capabilities and resource prospecting possibilities. So, VIPER will return to the Moon, though not on Griffin 1. This position has been reserved for another rover. After NASA canceled the VIPER mission, Pittsburgh-based Astrobotic began seeking alternative payloads for its Griffin 1 lander. In an interview, Astrobotic CEO John Thornton said, "We cast a wide net when NASA told us that VIPER was going to be canceled. We took a deep look at all of those potential payloads and filtered by who can be ready first, who's got the tech that can get a payload together that quickly, and then who's got the interface that's most closely aligned with what Viper's interface was. Luckily, they found it. Astrolab's FLEX Lunar Innovation Platform FLIP rover will serve as the primary payload aboard Astrobotic's Griffin 1 lander, which is set to land in the Nobile region near the Moon's southern pole. This rover coincidentally is a perfect replacement for the Viper. FLIP is a robotic four-wheeled vehicle weighing approximately 450 kilograms on Earth, with the capacity to carry up to 30 kilograms of payload. Given the close resemblance in size and mass to Viper, minimal adjustments will be required for its adaptation. Thornton said, "There were almost no changes to the lander for FLIP, and that's what made it great." Well, it turns out it was no accident at all. Jarrett Matthews, chief executive of Astrolab, said in an interview, "We understood as well that it's beneficial to both parties to have as few changes on the lander as possible. So we really designed FLIP to interface seamlessly with the existing Griffin design." Both companies are actively preparing their vehicles for a launch slated for the end of this year. Thornton mentioned that Astrobotic is developing key components of the lander's propulsion system and has found effective solutions to the valve issue that hindered its first lunar lander, Peregrine, shortly after its January 2024 launch. Other spacecraft components and software are also progressing as planned. Along with its lunar exploration mission, FLIP will test critical systems like full-sized batteries, tires, avionics, sensors, and software that are integral to Astrolab's larger FLEX, Flexible Logistics and Exploration, commercial vehicle. Jarrett Matthews, founder and CEO of Astrolab, said in the same statement, "By joining Griffin Mission 1, we will gather key insights into how lunar rovers like FLIP and FLEX operate in real lunar conditions. The FLEX rover is a versatile and rugged vehicle designed to support lunar exploration. It can transport 2 astronauts in full spacesuits, house a robotic arm for advanced scientific research, assist with robotic cargo logistics, and endure the extreme temperatures of the lunar South Pole. FLEX rover offers the flexibility to be remotely controlled from Earth when astronauts are absent or operated directly by astronauts on the surface. As a key asset for future missions, the FLEX rover will play a crucial role when astronauts return to the Moon." Astrolab developed the FLEX rover in alignment with NASA's Lunar Terrain Vehicle LTV specifications, with plans to deploy a fleet of FLEX vehicles across the Moon's surface as part of the Artemis program. "We've designed a logistics system capable of transporting a diverse range of cargo, aiming to establish a permanent lunar outpost more efficiently and at a lower cost than initially planned," said Astrolab founder and CEO Jarrett Matthews. The engineering team behind FLEX also envisions the rover playing a pivotal role in future Mars missions, extending its capabilities beyond the Moon. On mission day, FLEX will launch on a SpaceX Starship atop a Super Heavy booster. Of course, we cannot fail to mention Intuitive Machines' second awarded flight, IM-2. This lunar mission is set for late February 2025, led by Intuitive Machines under NASA's CLPS program, with a Nova-C lunar lander named Athena. The mission's goal is to explore the presence and quantity of lunar water ice using the Prime 1 payload, which includes a drill and mass spectrometer. In addition, the lander will deploy a micronova hopper, a drone equipped with a neutron spectrometer to explore the permanently shadowed region, PSR, of the nearby Marston crater. If successful, this mission will provide the first measurement of hydrogen in the PSR, offering critical insight into the presence of water on the Moon's surface. This will also be the first on-site, or in-situ, resource utilization demonstration on the Moon, utilizing a drill and mass spectrometer to measure the volatile content of subsurface materials. The Moon has captivated our imagination since the 60s, and it continues to be a destination that sparks our curiosity today. That's why we send landers and rovers to its surface, They lay the foundation for our future exploration and the eventual establishment of bases. With NASA leading the charge and SpaceX as a powerful partner, let's keep making our mark on this planet. The moon is within our reach,